Good afternoon, everyone, and welcome. My name is Kristian Nese. I'm CTO at Lumagate, and I'm here today to talk about Azure Pack. So before we start, anyone here ever heard about Azure Pack before? Okay, great. Using it? Cool. I just have to say, I was in Copenhagen a couple of months ago presenting something. Was waiting to get the session started, but instead of having the actual session title on the screen, I had something different. So it said, deploying Notepad, lesson learned from the field. That's a joke. So I was standing here, watching the entrance, people coming in, watching the screen, and like, what the? And they left. So I'm not doing that again. We're going to talk about Azure Pack, of course, how we deploy it, and perhaps more interestingly, how we are using it today, what we see customers are doing, what are the capabilities, and we're going to also have a look at a case study. So there are actually real-world organizations using this today. So I have to be honest, I might either have too many slides or too many demos. I'm not sure, time will tell. But I will try to focus on demos. Sounds okay? So the agenda, of course, is how are we actually deploying Azure Pack today? There are many ways to do that. It might be complex. It might be a big beast. It can be simple. So let's have a look at the options and what people actually are doing. We'll then have a look at the different resource providers. So if you are not familiar with the concept of resource providers, I will show you and explain that as well. And last but not least, we will show a case study where Azure Pack is quite important. And as always, my friends, a lot of demos. I haven't tested any of them, so I'm not sure if it will work. But let's see. Should be fun. So, deployment models. If you have ever tried Azure Pack, you have perhaps tried to just download it using Web Platform Installer and install the Express Edition. True? Some hands? Yeah? So, just to be clear, before we start, Azure Pack is something you deploy within your own data center. It has nothing to do with Microsoft Azure, except the consistency, of course, but it's something you deploy and something you operate and configure. So we have different APIs and sites of Azure Pack that we should consider as something that we keep within our firewalls, behind the firewalls. And we have something that we can and should expose to the internet if we want to provide services. So we have the admin stuff and we have the tenant stuff, as I will show you. To summarize, these are all the components involved in a typical Azure Pack deployment. So as you can see, we have several portals, sites, APIs, we have resource providers, and we have something called infrastructure. You can at least calculate one virtual machine on each of those APIs and sites and resource providers and infrastructure. And according to best practice, you should have 2 for load balancing and failover. Right? Starting to become a bit complex. But again, we see that people are doing this a bit different. So let's first cover the Express deployment architecture. You have 2 options when you download and install Azure Pack. It's either to use the Express or choose a distributed model. When you use the Express, you install everything within the same virtual machine, both the backend stuff and also the tenant stuff. And you also get all the resource providers within the Azure Pack framework. Then you connect to your resource providers like the VM Cloud, Website Cloud, or SQL Server Cloud, and start offering services. So the Express deployment is something we normally just see in lab environment or testing. But we have also seen people deploying it into production. And we have, of course, fixed that. And we then have a basic distributed deployment architecture. And this one is quite common because they start to deploy the Azure components. They don't think it's that important to have load balancing and failover at the application level. So they are quite comfortable by putting 3 virtual machines or a single virtual machine into the public zone. And they have the admin portals, the admin APIs, and the resource provided considered as privileged services located behind the firewall. So this is the basic distributed deployment architecture. And of course, they connect the resource providers in the backend. So, but what we are seeing today is more or less this deployment module being used. So here we have at least 2 virtual machines covering the public internet-facing part. So this is where we have installed the tenant public API and the management portal for the tenants. This is accessible and exposed on the internet, okay? We then have the admin portal, the admin API, and also the tenant API located behind the firewall on 2 virtual machines as well. So here you can see we are using load balancing on both. In addition, we are using Active Directory Federation services for the identity part of the solution. And we of course have a highly available SQL environment. So in total, as a minimum, we have 6 to 8 virtual machines using this configuration. And that's quite an advantage compared to the really best practice where you have everything installed on a single virtual machine. So we are reducing the footprint and using this deployment architecture. And here, the good thing here is that we can easily scale each instance once we have it configured. And perhaps a bit confusing. We have customers that really don't want the Azure Pack footprint at all. They just want the solution plugged into their data center so they can start to expose and provide services to their customers. We found out that using Microsoft Azure as the platform for hosting our Azure Pack environment is quite brilliant. So there we can script the entire deployment. We can use the already inbuilt load balancing mechanism in Azure, and we can deploy the entire Azure Pack environment. We plug in to our own data center using the site-to-site connection, and there we go. So using Azure as the distribution model here. All right, let's jump to the first demonstration of Azure Pack. So I will cover some couple of technologies here. I will show you first how we actually do the reconfiguration of an Azure Pack installation. We're going to have a look at the SideState Configuration. Are you familiar with that one? Some? Yeah? And Azure as well. So just to show you some examples on what we are doing and what you can do. So the first thing I'd like to point out is that this is a tenant virtual machine. Sorry, this is a Azure Pack virtual machine that is hosting the tenant public API, the tenant side, and the included .NET membership authentication side for Azure Pack. So this is installed automatically. If you would like to use ADFS instead, you can replace that. But I just want to show you that when you install the Azure Pack environment, default, you can see that the tenant side are using some default ports. So this is not something we can use across different firewalls. So we have to do some reconfiguration. We need also to specify the host name we're supposed to use, and of course use a valid certificate. So all of this is things you'll have to do after any Azure Pack deployment. So just to show you, if we check the so a default install. So this is the first Windows Server where we install the tenant public API and the tenant portal, it will be bound to the local hostname of that machine. We would like to change that to a different qualified domain name. We'd also like to change the port. So using the default .NET membership site will first send us to let me show you. First send us when we are accessing the tenant portal. It will then redirect us to the tenant authentication site, which is using a different port as well. We get then verified that we should have access, and we are redirected back to the tenant site. However, we need this to work across firewalls, so I obviously have to change something here. So let's change the tenant site into Demo Portal System Center 365. So obviously the first thing we'll have to do is to change the bindings. I will use a certificate, and also I will use server name identification. So I can use multiple websites using the same port, differentiating in the host header. I do the same for the authentication site. Just checking that I have the right name. Of course, these records need to be registered in DNS before you do that. Okay, so if I now try to talk while I'm writing, I'm obviously not succeeded. If I now try to access the demo portal, which is the new name, the new fully qualified domain for the solution, you can see that nothing gets displayed. So I need to change this in a supported way through PowerShell. So here I'm first defining the fully qualified domain for the portal. I then do the same for the authentication site. I re-establish the trust between the portal and the authentication site. I said I haven't tested this before, so let's see how it goes. Oops. I have one tip regarding PowerShell, and that's to don't have any typos. Let's try again. Okay, so if I now try to navigate to demo portal, I should get access to the tenant portal, redirected to the tenant authentication site. As you can see, I can sign up as a new tenant. And I get redirected back to the tenant portal. So this is how you do the simple reconfiguration of the fully qualified domain and the ports of the portals after the installation. So obviously there are some things you need to do after the installation of Azure Pack. So wouldn't it be great if we could just automate it, the entire process? Let's just define this is how it's going to be and make it so. Yeah, I agree. So that's why we have something called the SideState Configuration. So if you're not familiar with this, this is like a new way of doing configuration and deployment of sophisticated solutions. So it's not an agent-based solution. We are using the local configuration manager on each and every virtual machine. So in this example, I'm using the push method. So I'm pushing this through Windows VS Management. I could also have a pull configuration through either SMB or HTTP, HTTPS, if this was for a serious setup. But this is just to show you the Azure Pack, the SideState Configuration resource. So it's created by, oh, I have the wrong input. It's created by Rob Wills on the Enterprise and Customer Group CAT team at Microsoft. So you can download this resource. So what we are doing here, we are specifying some parameters. We are defining where to find the binaries. We are configuring all the APIs, the endpoints, the resource providers. We are configuring this in a high available mode with a dedicated SQL. So this is, and of course, this is using, we are using Windows Management Framework 5.0, which is in a preview. So there are some bugs. Okay, so now I'm running it. So by the end of, well, in a couple of hours, I should have a new complete Azure Pack environment. So we will not sit there and watch this, of course. But if you find me later, say, hey, prove me that it actually worked. So this will now copy files, do installation, and all of that. So the thing I like here, and now you're seeing we are doing this in the private cloud, okay? The good thing is that we can, of course, use this in the public cloud as well. So let me find the same setup. So I'm now logging into one of my virtual machines running in Azure. And hopefully it's still up and running to show you the Tenant Portal. There it is. So here you can see we have the Tenant Portal running on a virtual machine in Azure, deployed through the SideState Configuration. And that's quite cool. That means we can just deploy this and say to a customer, hey, you want Azure Pack? All right, let's plug it in. So that was a bit around deployment of Azure Pack. There are many ways of doing it today. And hopefully you got some tip there. So what about the resource providers? We have just spent quite a few minutes on things that are not that interesting really, because the Azure Pack solution is not the one you really care about, but the actual services you are able to provide and how you are able to provide them. Agree? at least from a business perspective. It's always nice to cuddle with the technology, but let's be honest. So let's have a look at the resource providers. And a resource provider is something you use into the service management API in Azure in order to deliver services. So it could be virtual machines, for instance. It could be SQL. So the pattern here, as you can see, is that we have the management portal. We have the service management API, which is common to Azure. And out of the box, using only the solutions from Microsoft, we have the following resource providers. We have the VM Cloud resource providers, which gives you infrastructure as a service. We have the website and SQL, MySQL, and Service Bus that gives you platform as a service. And the key here is the consistency we see from the Azure portal. We have these services available for us to use on-premise now, and moving forward, we will see that more and more services from Azure will become available on-premise. So what we're seeing at customer sites is that the VM Cloud resource provider is, of course, the most interesting part. It's also the most complex part, and it's also where people are doing all the mistakes. Because there are things to be aware of, to consider before you actually start using this. So let's have a look at the architecture involved. The Azure Pack is on top. We have the management portal. We have one portal for the administrator where you configure the resource provider. You define the hosting plans that contains all the services you intend to offer. We also have a tenant portal that we have seen where the tenants or the customers are accessing and get access to their resources. Both portals are using the service management API, where we have connected, in this case, where we are talking about the VM Cloud, we have connected Service Provider Foundation. This is a multi-tenant REST OData API that was introduced in 2012 Service Pack 1. So this literally make it possible for our organization to leverage the multi-tenancy technology in Windows Server with Hyper-V. So we basically are exposing the configuration created in Virtual Machine Manager into Azure Pack. So this is basically the architecture. And as you can see, we have a concept called stamps. We have two stamps here, and a stamp basically reflects a Virtual Machine Manager environment. And a Virtual Machine Manager can have several host groups, can have several hosts and clusters and clouds, so it can really get quite messy. So let's talk a bit about the multi-tenancy. We have a hosting plan in Azure Pack that is associated and bound to a VMM cloud and a VMM server, right? A cloud and VMM can contain one or more host groups. You can have several hosting plans using the same VMM server and the same cloud. You can have several hosting plans using the same VMM server and different clouds. You see where I'm going with this? I'm just trying to confuse you as much as I can. Of course, you can also have several hosting plans using different VMM servers and different clouds. Oh dear. So where do we start to design this? And what's the intention? What's the goal? What are we building? Right? Of course, let's not forget about Service Provider Foundation. That little component supports up to 5 VMM stamps. If separates domains, VMM domains must trust SPF. Each stamp is an isolated stamp, meaning you can't communicate across stamps. And Windows Azure Pack supports only a single Service Provider Foundation endpoint. Perhaps that don't make any sense right now, but let's show some examples. So we have a one-to-one mapping, and here you can see all the different layers involved. We have the tenant subscriptions on top. We have the hosting plan created by the administrator in Azure Pack, living in the Azure Pack environment. We are using the Service Provider Foundation endpoint that expose the VMM cloud, which is based on a VMM server and one or more host groups. So that's the architecture. So let's see how it scales. We can have one-to-many mapping. So we can have 2 host groups in one VMM server exposed in one VMM cloud where we have created a single hosting plan. We can have 2 hosting plans or more accessing the same VMM cloud using the same host group in the same single VMM. We can have 2 hosting plans targeting different VMM clouds using the same VMM server using a single host group. We can of course have multiple clouds, VMM server and host groups and hosting plans. And last but not least, we can duplicate everything. So this is a scenario, the one you're looking at right now, where you are using the inbuilt integration of Azure Pack with Azure Site Recovery. So here we have a complete disaster recovery solution on the entire environment. And that looks something like this. We have the Azure Pack, we have 2 Azure Pack environments. The virtual machines in the managed portal are replicated onto the recovery environment using Azure Site Recovery. Okay, another demonstration then. So what's important here is to know what you're doing, obviously. So designing VMM is essential. Yeah, here's the SideState configuration running. So let's start with a blank VMM server. So what people are really doing today when they have installed VMM is something like this. You create a host group. And they call it, what do they call it? Of course they call it Hyper-V, because that's what they're putting into it. And they create a network. They don't know about the name, so they just say management. They definitely do not know anything about the network types. So let's just do it like this. There we go. That was the worst thing we could ever do. Because now we have created that host group and we have created a network that has access to all hosts. Meaning, when you try to deploy a virtual machine into any host using this network, you will succeed. So you have literally no control where you're deploying the virtual machines. And that's important to have that kind of control when you're dealing with Azure Pack, because the intention, of course, is to scale, to make money out of it, and know where things are going. So let's quickly do a cleanup. And run a script. That hopefully shows a different design. And this is a design that we are using, and it works both together with Azure Pack environments today for the VM Cloud Resource Provider, and it works with Azure Site Recovery. So in this example, we have a single VMM managing different locations. We have Copenhagen, we have Oslo, we have Paris. So these host groups are sort of just the abstraction of where things are happening. Within each location, we have different host group for functions. So we have a dedicated host group for edge components, meaning virtualization gateways. We have host group for our Hyper-V host running the management workload. We have the customers running the IaaS workload, and we have disaster recovery host as well. So if you go to VMs and services, you can see that on each of these locations, we have a dedicated cloud. And we can further use this configuration into Azure Pack so the customer can decide if they would like to deploy the workload into Copenhagen, Oslo, or Paris. We can also create a cloud that is called something like Europe, that is including all the host groups. Another layer of abstraction. So let me quickly go back to the live environment. And here you can see it. So here we have the Copenhagen host group with the fabric management host. We have the IaaS hosts. And this host group is used into the Copenhagen cloud. Meaning all the deployment that goes into this cloud will be running on this host group. So once the configuration from the VMM side is done, you can see that this is where we are connecting Azure Pack to Service Provider Foundation. As I showed earlier on a slide, that we only support one SPF endpoint. And this is it. Once it's connected, we get access to the management stamp that is associated with Service Provider Foundation. So here you can see the VMM server we have and also all the clouds created in VMM. So it's the same information we have here. All right, so the VM Cloud Resource Provider is now in place. As an administrator, we can now go to plans and we can configure a new plan. We can call this for the NIC Oslo. I would like to use the virtual machine clouds. Actually, I'm going to use and depending on the other resource providers you might have associated with the Azure Pack environment, they will be available here. So here you can see we have the website, SQL, and even Cloud Cruiser. So I will pick virtual machine cloud for now. It will create the plan. It will be marked as private, and it also requires additional configuration. There we go. So here you can see it's not configured. And that's what we're about to do now. So first we associate the hosting plan with the management stamp. We then pick VMM cloud. So here you can see that the hosting plans are bound to a specific VMM server and a specific VMM cloud. We then specify the usage limits, the settings the tenants are supposed to do, and click Save. So if I now make this plan public, I can let tenants subscribe to this plan and consume resources. So as you can see, this portal reminds us a lot of not only Microsoft Azure, but the Tenant Portal we looked into earlier. So what's interesting here is that we also have something called automation. And I know there's a lot of good sessions during NIC around service management automation, or SMA, and this is where everything comes into play. We can use the SMA endpoint into Azure Pack. We can define and create runbooks, and what we are using in particular are runbooks associated with different tasks happening in the Azure Pack environment. So let's say a user creates something specific. Then each time that is created, we run a specific runbook. So let's just quickly have a look at it. So this is where I have a runbook here that will run on a schedule. So every evening, it should check for any checkpoints on a specific host group. If any, then delete them. So let's see if there are any now. There are other people using this environment, so there might be some checkpoints. this should communicate to the VMM environment. So what I'm trying to say and show here is that if there are specific functions or things you are missing in the management solution today, you can easily build them by yourself. So we are closing the gap by using SMA in many situations. So they found one checkpoint and deleted it. So the job should be completed. So it's working. So automation is, and the good thing here is the transparency we have again with Azure using Microsoft automation, Microsoft Azure automation. So here we can link an action with a runbook. Let's say SPF VM each and every time we sorry. You can link objects to specific actions and then link to the runbooks you'd like to trigger. That's the concept and idea here, and it's the imagination is the limit, as I will show you a bit later. So far we have just talked about the VM Cloud Resource Provider, and I guess everyone here is quite familiar with virtual machines today. You deploy a virtual machine, you generalize the operating system, and you can redeploy it, right? Creating virtual machine templates. It's common knowledge in these days, yeah? But what we are seeing is that people are, first of all, they are not impressed of a virtual machine anymore. They want more. Let's say, wouldn't it be great if we could deploy complex application? We can present it in a way that even our parents would be able to deploy it. I think that would be quite cool. So that's why we have the concept of virtual machine roles in Azure Pack as well. We have a consistent way of delivering applications both in the public cloud and the private cloud through Azure Pack now. And I will show you that. This is the part of the session where it becomes a bit complex. So a virtual machine role is similar to service templates in VMM, but it's very different at the same time. Are you familiar with service templates in VMM? A couple of hands? Yeah? So that's a way you can sort of design your services and applications. You're doing more than just a virtual machine. You can add some application payload to a virtual machine, and you can even configure it. So doing this in VMM with service templates requires access to the VMM console. So what customers really want is a way to do this once for any cloud and deploy it to any cloud. So that's why VM roles is a bit different. It gives you more than just an operating system, as I will show you. It simplifies the deployment of complex applications. We can use the beautiful Azure Tenant Portal to expose the capabilities, where you as a user and tenant just type in the inputs and deploy. It's easier to do lifecycle management. Let's say you get an update of an application, or you would like to service the entire service. You can do that now. And of course, we have cloud consistency. You can use the same artifacts and deploy it to Azure as you can to Azure Pack today. So, a VM role overview. We have two packages. We have something called REST definition. This is, to put it simple, it's a language that the Azure Pack JSON is able to talk and understand. So this is something we import into Azure Pack. Then we have something called REST extension, resource extension. And this one talks a language that VMM understands. So this is where you are creating the application payload, you're using any script and dependency and all of that, and you import it into VMM. So it's quite, it's a bit of a learning curve to start with this, but once you are into it, it's a very fun experience. So let me show you. I will start by showing this from a tenant perspective. So now I will sign into the portal as myself. And here you can see I have several virtual machines. If you look closely, you can see that the type of some of them are role, while the others are standalone. So clicking New, let me either deploy a virtual machine role or a standalone virtual machine. Now, you all know everything about a VM template, so let's have a look at the virtual machine role. So depending on you, the administrator, and what you are exposing and delivering through the hosting plan, you have to dive into the gallery to get access. And here you can see we have several virtual machine role configurations. We have a demo server, we have a domain controller, we have a SQL server, we have a web server, and we have a Windows Server 2012 R2 file server. So this is something I created last night just to show you how we are interacting with the different resources. So this is nothing very fancy, believe me. Let me explain why. So let's first click Next. We first have to define a name. So let's call this NIC SMB. You can see we have different versions. Right now only one, but we can easily add a new version of the virtual machine role. So I click Next, and here we specify the VM size. If you're familiar with Azure, you might recognize this. So here I even had eight virtual machines in this stamp. We target a specific disk. We define the password. We can specify the time zone. Oops. And we can also specify VM role computer name pattern. We connect it to a network and also specify the workgroup name. So try to remember all these properties here. We go to the next screen, and here you can see that we can create a folder and we can create a share. So that was the thing I created last night. Impressive? So I will create a folder called NIC folder, and on that folder I will create a share that is NIC share. So that's the intention here, that I deploy a file server that has already created a share exposed to my users. So click Next, and this will now, if we go into the fabric again and check what's going on, we can see that we have a new job where we are running, here it is, SMB NIC, where we are deploying this virtual machine role. So, how did we create this VM role? Okay. So, if you are like me, like constantly forgetting your black belt in JSON every day, you might find this tool very handy. It's the VM authoring tool. It's created by some Microsoft people, available on Codeplex. And you can see that the VM role I just deployed, it's called NIC role. It contains two files, well, two artifacts like the resource definition package and the resource extension package. Those are the two packages I have imported into the VM role authoring tool. So if we first look at the resource definition, which again is the language that the Azure Pack portal understands and talk, this is where we define the scale out. You remember that we saw a machine name pattern, right? If I choose to scale out this VM role afterwards, it will have a pattern and maximum 5 instances. We have operating system profile. So here you see we could specify the workgroup. I could instead choose to join it to a domain. And we have the view definitions. So these are the pages that the tenants were seeing in the portal. So the first one was the VM configuration, where we'd specify the VM size, the pattern, and so on. And then we have the share configuration, the folder and share. So here it is, the folder name, specify folder name, and that's quite simple. I could just add anything here, but that doesn't have to mean anything unless I have something to map it towards. So that's why we have the resource extension package. So as I said, this is the application payload that you import into VMM. And here I have added a provisioning script. You can see that we are pointing towards a custom resource that I have uploaded and associated with this resource extension. And if we go into the folder, we have a script, a PowerShell script called demo NIC. So what is this script actually doing? We have some parameters here that we are exposing in a portal. So this is where the tenant typed in the folder name, and this is the share name, and this is the single line that created it based on the user input. I've added the script here. I have uploaded and associated with the resource extension. The parameters are available here. This is also where you enable any Windows Server feature and role. You simply click it, and it will be enabled and installed. But in order to configure it, you have to use the application scripts. Sorry, the application profile. So this will execute PowerShell using these parameters, and they are exposed in the portal. So once we're happy with the configuration, we save it. In the admin portal, we go to VM Cloud, we go to Gallery, and we import the resource definition. I've already done that, and this is the resource definitions you are seeing. So the one we were using was this one. You then need to make it public and accessible to users. And most important, you must add the gallery item to a hosting plan. So we can now add this gallery item or VM role into the NIC Copenhagen hosting plan we created earlier. Like this. So if I go to my account and sign up to an additional plan, I should have the NIC Copenhagen I created. I'm selecting only that plan, and you can see that the services are now limited to only virtual machines, as that's what we were adding to the hosting plan. So the only thing I should be able to deploy here is the file server that I just added. Okay. Let's quickly go back to the presentation. So that was the virtual machine role. I just did some things very simple, like creating a share based on a folder, based on input from the user. But being able to leverage PowerShell into all of this gives you a lot of possibilities. So what about website clouds? People are actually using that as well. So if we're talking about consistency, that is a very close consistency to the things we have in Azure. So the website clouds are there for you to deploy your web applications to an Azure Pack environment. So again, this is where we are touching the platform as a service offerings, and the website cloud is also tightly connected to the SQL Server Cloud and the MySQL Server Cloud, and also the Service Bus. So in other words, might be very applicable for developers. So there are ways for them to interact with the APIs as well. So the website is, of course, scalable. It's multi-tenant. You can use it in the same way as you're using it in Azure today. It scales horizontally and vertically. It's automated. It's based on some Windows servers in the backend that you can easily configure and deploy through the Azure Pack management framework. It's flexible. It supports several developer languages. You can integrate it to lifecycle management solutions, and it's quite handy actually. So the architecture we need to get this established consists of several server roles. We need a controller. And of course, most of the things there can be highly available and scalable as well. So the controller is responsible for provisioning and manage the other roles. We then have a management server, which is the REST endpoint that we connect to the admin API in Azure Pack. We have one or several worker roles. We have front ends that accept the web request, as I will show you. And we also have publisher. And in addition, the dependencies are a file server where we are downloading the application packages and so on, and also the database to contain the entire environment. So let us have a look at the platform as a service solution in Azure Pack. So going into Azure Pack again, you can see that I have something called websites. This is now in the Tenant Portal, and here you can see I created something earlier today called Kristian Nese. I can click on the URL, and I get access to, obviously, a new blog I just created. So you can all check it, typing this URL. It should be live and accessible. And just to show you how easy we can now create applications, I will create a new one. So I will go to website. I'm clicking from gallery that is now connecting to the web application gallery. And this is where I can get all kinds of applications, basically. But the application I would like to show now is something that connects the website cloud with the SQL Server Cloud. So here I need to specify the URL. NIC app. It's available. I will create a new SQL database. NICDB. So it will take a couple of seconds before we have a new web application up and running. So while we're waiting, we can have a look at the SQL database as well. So this is very popular in the enterprise, especially because many customers or many organizations, they have quite a big need of SQL servers. So each and every time someone needs a database, people are deploying a SQL server. Now we are just putting a single SQL server. We can use a SQL cluster into Azure Pack, and instead of getting access to a complete SQL server, they can get their databases. So it's quite simple. We create a new database. We define the admin name and password, and OK. Once it's created, we can get the connection string we need to our application, and that's it. No need to fuss around with the entire SQL server. And you also save a lot on licensing. So let's check the web application. It's still creating. We have other applications here. So here is where I store all my pictures. Of course, when you have deployed something here, you can interact with the web applications in different ways. We can have web metrics, you can use Visual Studio, and here you can download the publish profile. So you can add this directly to the Visual Studio you have and connect and work and access the tenant public API. And that's quite consistent to what we have in Azure today as well. Okay, I better hurry. So, the last thing I'd like to talk about is the case study that we have been doing for the last couple of months. It's a pretty big organization here that has deployed Windows Azure Pack, and literally all the resource providers plus more. And there's a good customer reference. It's a case study that is publicly available now. And I'm talking about Every. They have a deployment where the Azure Pack environment is highly available. It's a scale-out deployment. And as you can see, the resource providers, and we have today been talking about the VM Cloud, the Website Cloud, SQL Server Cloud. They are also using the Service Bus Cloud, MySQL, and also something called Request Management by a Microsoft partner called GridPro. So the request management solution is particularly interesting because that enables Service Manager, System Center Service Manager, to be available in Azure Pack. So you can create your request offerings in Service Manager, and they are automatically exposed into Azure Pack. So why did we do this? Well, of course, talking about cloud consistency again. Every wanted to be similar, but also different than Microsoft Azure. So in order to drive cloud consistency, not only internally, but also externally towards customer, it's important to provide the same set of services. They'd like to be able to publish new services every 4th month or so. And they're focusing on managed services for the infrastructure as a service part, meaning managed backup and managed disaster recovery, which the customer case is all about. So let me show you the portal and some tenant automation here in the end. So going to this address, we are entering the tenant portal at Every. So here I'll type my credential. And I'm redirected back to the tenant portal from the ADFS STS server. And here you can see I have all the resource providers available in the subscription I have access to. So we have been covering many things already today, but as you can see here, we have request management. So this is where we can now provide new service offerings using Azure Pack together with the GridPro solution. So what will be available here, it all depends on what we're trying to deliver. So here we can we can right now on this hosting plan create a generic incident request, like something is wrong with the system, or we can also add managed backup to our virtual machines. So this will effectively do some automation in the backend, targeting my virtual machines to that subscription. So that's quite cool. So the last thing I'd like to show you is tenant automation, and I will not do it towards the every portal, but I will do is towards my own demo environment. And here you can see by adding the publish settings at the end of the URL, and this is the exact same experience you get in Microsoft Azure today. It will generate a publish settings files that contains information about the tenant public API we are about to access, and the portal and all the settings related to that subscription. I've already done that, so I'm having a few commandlets here. So first of all, as I said earlier, the service management API of Azure and Azure Pack is the same. So in order to automate towards the tenant public API, we are actually using the PowerShell module of Azure. So by running this commandlet, get all the commands related to Webpack, you can see that the module is Azure. So here we can do many different things related to websites, virtual machines, and all of that. And that's what I'm going to do now. So first, I will add the Azure Pack environment, import the publish settings file, get the Webpack subscription. I will select the one I like to use, and now I can start to access the tenant public API, like getting all the VM roles I have deployed. So I should bring up the portal here as well so you can see the actions are taking place. So here's the VM roles. Here's the SMB NIC or NIC SMB I just deployed. I can get the information about my virtual network. Here it is. I can create a new subnet. But what I like to do now is to create a virtual machine. So first of all, I'm getting a template that is available on that hosting plan. I also get the VNet I'd like to deploy it to. I specify some credentials. And I will create a single virtual machine in the Azure Pack through the tenant public API. So clicking here will effectively here. It's creating now NIC virtual machine 100 getting deployed into the Azure Pack Cloud through the tenant public API. So customers can also automate into the Azure Pack Cloud as well, not only Azure. So I'm a couple of minutes over time, I think. Just quickly want to let you know that update rollup 5 was released earlier this week for System Center and Azure Pack. What's new here is that the VM role I've been talking about is now supporting standard static disks. It's a long story. We finally support it, so no worries around the differential disks in the VM roles. So many people are happy now. We also support SQL Server Resource Governor with SQL Server 2014 in Azure Pack. There are also support for disabling native network resource providers. So if you are if you don't want to expose any network settings to the tenants, since you're not using network virtualization, you can disable that now. And also tenants can now see information about what kind of dynamic memory their virtual machines have. So you can reach me here if you have questions about this or would like to see more, we have a booth, number 22, I think. So please join and we can talk there. Thanks, everyone.